Good day, viewers. Welcome to today's class. Today we're looking at JAMB Physics past questions. Let's dive right into it. Question number 1 says, the slope of the straight line displacement time graph indicates dash. Now, what they're asking you is, if I have a displacement time graph, so I have, here is displacement, and this is time. So, if I have the graph looking like this, the slope of the graph, what is the slope of the graph? That's the question they're asking. And we know that slope is always equals to change in the vertical axis, in this place displacement, over change in time. So they're asking us, what is distance or displacement over time? So displacement over time is the question they're asking us. And option A says it is distance traveled. Option B says it is uniform velocity. Option C says it is uniform acceleration. Option D says it is uniform speed. Now we know that both speed and velocity are very much alike, but the difference is one has to do with displacement, the other one has to do with distance, making one a scalar quantity and the other one a vector quantity. In this case, the correct answer is going to be uniform velocity, reason being that it's talking about what? Displacement, as velocity is what? The rate of change of displacement. So the correct answer to this question is option B. Moving on to question number 2, it says, a man will exert the greatest pressure when he dash. So when will a man exert the highest amount of pressure? That's the question they're asking. So option A says when he lies flat on his belly. Option B says when he lies on his back. Option C says when he stands on both feet. Option D says when he stands on the toes of one foot. Now, when you stand on the toes of one foot, the entire weight of the man is concentrated on that toe, making what? It have higher pressure. So a man will exert the greatest pressure when it was standing on the toes of one foot, which is what? Option D. So that takes us to question number 3, which says, which of the units of the following physical quantities are derived? So they're asking us which of these units are derived. So looking at the physical quantities that we have area, we have thrust, we have pressure, and we have mass. And they're asking us which of these units are derived. So looking at this, what is the unit of area, for example? The unit of area is meter square. The unit of thrust, because thrust is a force here, the unit is Newton. Pressure, the unit of pressure is, because pressure is force per area, this is Newton per meter square. Then the unit of mass is kilogram. So the question is, which of the unit of the following derived quantities, physical quantities, are derived? So looking at this, you realize that what? All of them are derived except one. The only one that is not a derived unit there is that of what? Mass. So looking at this, meter square is the combination of what? Meter and meter. Newton here, talking about force, is what? Kilogram meter per second square. And you have what? Here also kilogram meter per second square times meters divided by meters square. So this, looking at all of this, you realize that these are what? The fundamental units that are present inside this derived unit. But if you are looking at what? Mass, it has only what? Fundamental units. So the correct answer to this question is one that has all of these three except this, which is saying that what? So if you look at our option, option A says everything, option B says 1, 2, and 3 only, which is the correct answer. So option B is the correct answer to this question. Moving on to question number 4, it says, a ball of mass 0.5 kg moving at 10 meters per second collides with another ball of equal mass. So we have a ball of mass 0.5 kg. So this is the first ball, M1, collides with another ball of equal mass. So our M2 is also 0.5 kg. of equal mass at rest. So remember that our M1 was moving at U1 10 meter per second, and our M2 was at rest, which is 0 meter per second. Then the question says, if the two balls move off together after impact, so they now have the common velocity. Calculate their common velocity, we do not know. But we know that momentum before collision is equal to momentum after collision. So that means that my momentum before collision, which is M1U1 plus M2U2, is equals to V open bracket M1 plus M2. So this is what the formula I'm going to be using, because they now have what? A common velocity after collision. So looking at this means I have 0.5 times 10 plus 0.5 times 0 is equals to V open bracket 0.5 plus 0.5. So this will give me 5 plus 0 is equals to V open bracket 1. That's the same as saying that my V is equals to 5 meter per second. So it means that their common velocity after impact is 5 meter per second, which is option C. Moving on to the next question, which is question number 5. It says, the motion of a body is simple harmonic if the dash. So the motion of a body is said to be simple harmonic, meaning that the body is said to be in simple harmonic motion if there is a certain condition. So option A says if the acceleration is always directed towards a fixed point. Option B says if the path of motion is a straight line. Option C says if the acceleration is proportional to the square of the distance from a fixed point. Option D says if the acceleration is constant and directed towards a fixed point. So looking at this, whenever a body is in simple harmonic motion, the acceleration is always directed towards a fixed point. So the acceleration is directed towards a fixed point. For example, if I have a simple harmonic motion in, let's say, your simple pendulum experiment, you realize that what the string holding the pendulum board is at a fixed point, it doesn't change, and the acceleration of the body is what directed towards that what fixed point. So the correct answer to this question is option A. Moving on to the next question, it says, which of the following is not correct about the molecules of a substance in a gaseous state? Option A, they are a constant state of motion. Option B says they have different speed. Option C says they have a temperature which is measured by the average kinetic energy. Then option D says the collision between the gases is perfectly inelastic. Now, looking at all of these options, you realize that whenever gases are kept in a container, whenever a substance is in a gaseous state, first, they are always moving, they are in constant motion, and their motion, the particles or the molecules have what? Different speed. They are not moving at the same speed, so they have different speed, and they have what? A temperature which is measured by their average kinetic energy. And also, the collision is what? Perfectly elastic, not perfectly inelastic. So the correct answer to this question, which is the one that is not what? A characteristic of what? Substance that are in gaseous state, is what? Option D, because the collision is what? Perfectly elastic instead of what? Perfectly inelastic. So moving on to the next question. It says, a given mass of a gas has a pressure of, so we have pressure, P1 as 80 Newton per meter square, at a temperature, θ1 as 47 degrees Celsius. If the temperature is reduced to, so we have θ2 as 27 degrees Celsius, with volume remaining constant, so the volume is constant, the new pressure is dash. So we're looking for P2. So looking at this question, you know that this is what? Gas laws. So the first thing I'm going to do here is to convert these two to become what? In Kelvin. So this plus 273 plus 273. So this will give me what? 300 Kelvin. And this will give me 320 Kelvin. So looking at this, the formula I'm going to be using here is P1 over T1 is equals to P2 over T2. So looking at this, I'll just impute my value. So I have 80 over 320 is equals to P2 over 300. So if I cross multiply here, I have 320 P2 is equals to 80 times 300. I divide both sides by 320 divided by 320. It means that my P2 is going to be equal to, so I have 80 times 320, 80 times 300, divided by 320. So it means that my P2 is 75 Newton per meter square. It means at the end of the day, my correct answer is going to be what? Option B. Okay, moving on to question number 8. It says 0.5 kilogram of water. So we have the mass of water to be 0.5 kilogram. So we have the temperature of water as 10 degrees Celsius. It's completely converted to ice. So let's say this is M1, this is theta 1. Completely converted to ice at 0 degrees Celsius by extracting. So the quantity of heat that was extracted was 88,000 joules of heat from it. If the specific capacity of water is, so our C of water is 4,200 joules per kilogram per Kelvin or per degree Celsius. Calculate the specific latent heat of fusion of ice. So we're looking for L, we do not know. Now remember that the water was originally at 10 degrees Celsius. So if it's at 10 degrees Celsius, it means for me to convert it to 0, I will have to what? First, extract the amount of heat from it to convert it to 0, and then what? Convert it from 0 by changing its state to what? From water to ice by changing the state. So here, it means that my quantity of heat is going to be what? The specific heat capacity, MC change in theta, plus my latent heat. So that's the quantity of heat that was what? Extracted. So here, because I'm converting it to 0, it means here that at the end of the day, what I'll be having here is this will become Q to be equals to MC. My change in theta here will become 10 minus 0, and this is plus ml. So L is what we are looking for here. So all I have to do is impute my value. So I have 88,000 is equals to the mass here is 0.5 times 4,200 times 10 is equal to 0 plus 0.5 L. So this will give me 88,000 is equal to, so I have 5 times 4,200. So I have 21,000 plus 0.5 L. If I collect like terms, I will have 88,000 minus 21,000 is equal to 0.5 L. So I have 88,000 minus 21,000. So that will give me 67,000 is equal to 0.5 L. Divide both sides by 0.5 divided by 0.5. It means that the latent heat of fusion of ice is going to be 134,000 joules per kilogram, because it does not have anything to do with what? Temperature. So it means that my latent heat of fusion of ice there is 134,000 joules per kilogram. But if you look there, they've already put it in what? Multiple and sub-multiple. So what I'm just going to do here, if I want to put this in multiple here, it means this will give me 134. 1,000 here is written as what? Kilos. So I have what? Kilojoules per kilogram. So 134 kilojoules per kilogram, which is what? Option C. 134 kilojoules per kilogram. Moving on to the next question, which is question number 9. It says, which of the following instruments may be used to measure relative humidity? Now, relative humidity can be measured using an apparatus called the hygrometer. Hygrometer. So the correct answer to this question is option C. Please note that there's a difference between the hygrometer and the hydrometer. Hygrometer is relative humidity. relative humidity is measured using the hygrometer, not hydrometer. So option C is the correct answer. Moving on to question number 10. It says, a source of sound produces waves in air of wavelength 1.65 meters. So we are given the wavelength of this wave as 1.65 meters. So it means that my lambda here is 1.65 meters. So if the speed of sound in air, so we are given the velocity as 330 meter per second. The period of vibration in air is, so we are looking for the period, we do not know. But we know that our period is 1 over frequency. So, and we know that the velocity of sound is equals to F lambda. So, if in place of, it means therefore that my frequency is also equals to 1 over period. So, if my period is 1 over frequency, automatically it means that my frequency is equals to what? 1 over period. So, which means that my velocity will be equals to lambda over period. So, looking at this, if I use these formulas to calculate it, it means therefore that I will have 330 is equal to 1.65 divided by period. So if I cross multiply here, it means I'll be having 330 period is equals to 1.65. So if I divide both sides, it means therefore that my period will be equals to 1.65 divided by 330. It means that the period is going to be 5 times 10 raised to the power minus 3 seconds. Or you can say 0.005 seconds. So looking at this, it means that the correct answer to this question is option B, 0.005 seconds. Moving on to the next question. It says, a boy standing some distance from the foot of a tall cliff claps his hands and hears an echo 0.5 seconds later. So this question is based on echo. So he hears the echo. So the echo time was 0.5 seconds later. So if the speed of sound is, so the velocity of sound was given as 340 meter per second. So how far is he from the cliff? So we are looking for his distance from the cliff. We do not know. But we know that distance is equals to velocity times time. Because we said that what velocity is distance over time. So if you interchange that, it means that my what distance is equal to velocity times time. But there is something, the distance covered for echo is always twice, which means that for me to get the accurate distance, I will have to divide this by 2 because echo is to and fro. So if I have a building here and then I'm standing here, when I make a sound, and the sound travels down to the end of the wall and travels back for me to hear it as echo. So it means that my time is usually not the correct time. So the time it takes for this particular sound to travel from this point down to this point is half the original time, which is why I'm dividing by 2. So it means that my distance here is going to be 340 times 0.5 divided by 2. So it means therefore that the distance to the cliff is 85 meters. So the correct answer to this question is 85 meters, which is option D. Moving on to the next question, question number 12. It says, which of the following is not a vector quantity? Which of the following is not a vector quantity? Be reminded that what a vector quantity is one that has both magnitude and direction. And we've done what a full video of this in our channel earlier, where we talked about what vectors and scalars. So a vector quantity is one that has both magnitude and direction. So they're asking us which of these does not have magnitude and direction, which of these have only magnitude but have no direction. So looking at this, Momentum, which is option A, has both magnitude and direction. Displacement has both magnitude and direction. Force has both magnitude and direction. But temperature has only magnitude but no direction, making it what? A scalar quantity. So the correct answer to this question is option C, temperature. So that is also question number 13, which says, calculate the heat energy required to vaporize 50 grams of water. So this question is still talking about what? Specific latent heat. Specific latent heat. So, but this is strictly on vaporization of steam. So looking at this, calculate the heat energy required. So we're looking for the quantity of heat required to vaporize. The mass is 50 grams of water initially at. Temperature of the water was 80 degrees Celsius. If the specific latent heat of, okay, we're given the specific latent heat, specific capacity of water to be 4.2 joules per gram per Kelvin. So here, there will be no need for us to convert our mass because we are already given in grams. So we just leave it as grams, as our specific latent heat and our specific capacity are both in grams. So we're also given the specific latent heat to be 2260 joules per gram. So there will be no need to convert to kilogram. So we know that our quantity of heat here that was what required, we first of all what convert this 80 to 100 because at theta 2, which is the boiling point of water for it to become what vapor, is 100 degrees Celsius. So our quantity of heat that will be required is specific heat capacity that will be required to what? Heat it from 80 down to 100, and then our specific latent heat that was required in converting it from what? Liquid water to gas, which was steam. So here it means my quantity of heat there will be equals to MC. My change in temperature here will become theta 2 minus theta 1. This is plus ML. So it means that my quantity of heat is 50 times 4.2 times my change in temperature here is 100 minus 80. This is plus 50 times 2260. So this will give me, so I have 50 times 4.2 times 20. So that will give me 4,200. This is plus. So I have 50 times 2260. And that will give me 113000. So if I add the two of them together, so I will get 117,200. So looking at this, it means I have what? 117,200 joules. So looking at our options, I think none of the options here have it, but I think option C here should be a typographical error. There should be another 1 here to make it what? 117,200. So the correct answer is 117,200. So that takes us to question number 14, which says, in a series RLC circuit, that is what? A resistor, an inductor, and a capacitor circuit at resonance, the voltage across the resistor and the inductors are 30 volts. So the voltage across the resistor is 30 volts and the voltage across the inductor is 40 volts respectively. What is the voltage across the capacitor? Now remember in the question they said that this is an RLC circuit and they are what? In series. But remember also that in the question they also said that it's what? At resonance. At resonance, your capacitor is always equal to your inductor. What do I mean? Your capacitive reactance is equal to your inductive reactance. So which means that the voltage across the inductor is also equal to the voltage across the capacitor. With that said, if my inductor has a voltage of 40 volts, automatically the voltage across the capacitor will also be 40 volts. So the correct answer to this question is option B, which is what? 40 volts. So that is also question number 15, which says, if the frequency of an emitted X-ray is, so we are given the frequency as 1.6 times 10 raised to power 19 hertz. The accelerating potential is, so we're looking for the accelerating potential, we do not know. But we're given E to be 1.6 times 10 raised to power minus 19 joules. And then we're given the constant, Planck's constant, to be 6.63 times 10 raised to power minus 34 joules seconds. Now, for us to calculate this question, our formula is simply saying that the accelerating potential is equals to E over E. And we know that E is equals to HF. So which means that my accelerating potential V is equals to HF over E. So with this, it means that my accelerating potential V is equal to, so this will give me 6.63 times 10 raised to power minus 34 times 1.6 times 10 raised to power 19 over 1.6 times 10 raised to power minus 19. So this will give me, so I have 6.63 times 1. So I have 6.63 times 10 raised to power minus 34 times 10 raised to power 19 times 1.6 divided by 1 times 10 raised to power minus 19 times 1.6. So 1.6 will cancel out 1.6 from here. So I'll have 6.63 times 10 raised to power minus 34 plus 19 minus 19. So this will give me 34 minus 19 minus 19. So that will give me 6.63 times 10 raised to power minus 34 plus 19 plus 19. That will give me 6.63 times 10 raised to power 4. So looking at our options, okay, they remove it from standard form. So this is give me 6630. So it means at the end of the day, what I'm going to be having is 66630 volt. So the correct answer to this question is option A, which is what? 6630 volt. Moving on to the next question, which is question number 16. It says, if the fraction of the atom of a radioactive material left after 120 years, so the time given is 120 years, so we have our fraction as 1 over 64. What is the half-life? T half is unknown. So in this question, all you have to do here is tell them that your original fraction is 1, because it was from this one fraction that what you continue dividing, because the original radioactive material is what? 1. So n naught is 1. So this means that we know that our n is equals to n naught times 1 over 2 raised to power t over t half. So this is the same as I have 1 over 64 is equals to 1 times 1 over 2 raised to power 120 over t half. So this will give me 64 here is 2 raised to power 6. So I have 1 over 2 raised to power 6. So I have, so is equal to 1 over 2 raised to power 120 over t half. So this is the same as saying that I have. So this will give me 1 over 2 raised to power 6, because 1 raised to power 6 is still 1, is equals to 1 over 2 raised to power 120 over t half. So the base will cancel out themselves. I will have 6 is equals to 120 over t half. So if I cross multiply, I have 6 t half is equals to 120. Divide both sides by 6 divided by 6. So it means that my t half is equal to 120 divided by 6 will give me 20 years. So it means that the half-life of this radioactive material is 20 years, and that is what? Option B. So that is also question number 17, which says a certain radioactive source emits radiation that was found to be deflected by both magnetic and electric field. The radiation is that. So now when a radioactive material emits radiation and that particular radiation is deflected by both magnetic and electric field, then that radiation is beta particles. Beta particles are what? Deflected by both magnetic and electric field. So the correct answer to this question is option A. So that takes us to question number 18. We say the inner diameter of a test tube can be measured accurately using a dash. The inner diameter of a test tube can be measured using a dash. Now, the inner diameter of a test tube can only be measured with an appliance that have jaws, and the appliance that can measure this is the vernier caliper. So, a pair of vernier calipers is used to measure the inner diameter of a test tube, which is what? Option D. That is also question number 19, which says two bodies have masses in the ratio 3:1. So M1 ratio M2 is 3:1. They experience forces which impact to them. Acceleration in the ratio, so A1 ratio A2 is 2:9 respectively. Find the ratio of the forces the masses experience. So we are finding the ratio of F1 ratio F2. But we know that F is equals to MA. So this means that I have M1A1 ratio M2A2. So this means that I'll be having my M1 is 3 times, my A1 is 2 ratio, my M2 is 1 times, my A2 is 9. So this will give me 6:9, which is the same thing as saying 6/9, and that will give me 2/3 or 2:3. It means that the ratio of their forces is 2:3, which is option C. Moving on to question number 20, it says particles of mass, so we're given the mass as 10 raised to power minus 2 kilogram, is fixed to the tip of a fan blade which rotates with angular velocity. So we're given our omega as 100 rad per second. Okay, if the radius of the blade is, so we have the radius of the blade to be 0.2 meters. We are finding the centripetal force. We do not know, but we know that centripetal force is equals to m omega square r. So this is the same thing as saying that my centripetal force is equals to 10 raised to power minus 2 times our omega is 100 squared times the radius is 0.2. So this will give me 10 raised to power minus 2, which is the same as saying I have 1/10 raised to power 2 times 0.000 times 0.2. So this will give me 1/100 times 10,000 times 2/10. So these two zeros will cancel out to 0, this 0 will cancel this 0, and that will give me 20 Newton. So it means that the centripetal force on this particle is 20 Newton, which is option B. So that takes us to question number 21, which says a lead bullet of mass. So we have a lead bullet of mass 0.05 kilogram. So a lead bullet of mass 0.05 kilogram. So we have our mass as 0.05 kilogram. M1, mass of the bullet, is fired with a velocity U1 as 200 meters per second into a block of mass. So we have a new block of mass 0.95 kg. So given that the lead block can move freely, so initially it could not move, so my U2 here was 0 meters per second. Given that the block can move freely, the final kinetic energy after impact is dash. So we are looking for the final kinetic energy, Ke. We do not know. And for us to find Ke, we have to find the velocity with which it moves together. So we know that the momentum before collision is equal to momentum after collision. So it means I have m1u1 plus m2u2 is equals to v open bracket m1 plus m2. So here it means therefore that I'll be having 0.05 times 200 plus 0.95 times 0 is equal to v open bracket 0.05 plus 0.95. So this will give me 0.05 times 200. So that will give me 10 plus 0 is equals to v open bracket. So if I add this together, this will give me 1. It means that my v is equals to 10 meter per second. Now that I've gotten the velocity, I will use this velocity therefore to find out the kinetic energy. So remember that in the question they say we should find the what? The kinetic energy, the final kinetic energy after impact. So they were moving after impact, so the total mass after impact is 1 kilogram. So and that 1 kilogram is my 0.05 plus my 0.95. So if I add it all together, I'm going to get what? 1 kilogram. So and I know that my Ke is equals to half mv squared. So this is the same as saying that my Ke is equal to 1 over 2 times 1 times 10 squared. So that will give me 1 over 2 times 100, and that will give me 50 joules. So it means that after impact, the kinetic energy with which they move is what? 50 joules, which is option A. Moving on to question number 22, it says a ball of mass 0.1 kg, so our mass is 0.1 kilogram, is thrown vertically upward with a speed, so we have a velocity of 10 meters per second to the top of a tower 10 meters high. So the height is 10 meters. Neglecting air resistance is total energy just after hitting the ground. So if it hits the ground, it means that total energy is our mechanical energy. So it means my mechanical energy here, my mechanical energy is our Ke plus our Pe. So here, because it is thrown on the earth, it means that my G is equals to 10 meter per second squared as a constant that was given in the question. So I will simply tell them that the energy is equals to half mv squared plus mgh. So that will give me 1 over 2 times 0.1 times 10 squared plus 0.1 times 10 times 10. So that will give me 1 over 2 times 0.1 times 100, and this will give me plus 0.1 times 100. So that will give me 0.1 times 100 will give me 10. If I divide it by 2, that will give me 5, plus 0.1 times 100 will give me 10. So that will give me 15 joules. So it means that the total energy of this body just before hitting the ground is going to be what? 15 joules, which is option C. So that is also question number 23, which says a car of mass 800 kg. So we have the mass of the car to be 800 kilogram. Attains a speed of 25 meter per second. So the velocity is 25 meter per second in a time of 20 seconds. They said the power developed in the engine is dash. So we know that we're looking for what? The power. And we know that power is equal to energy over time. So this is the same as saying that the power is equal to half mv squared over time. Why am I using this formula? Because from the parameters that I'm giving here, I can tell that this is what? Kinetic energy. And they're talking about what? A moving car. So it means that my power here, the power will be equal to 1 over 2 times 800 times 25 squared divided by 20. So this will give me that my power is 400 times, that should give me 625 times 625 divided by 20. So this will cancel this, 2 here 1, 2 here 20. So that will have 625 times 20. And that will give me that my power is 12500 watts, which is the same as saying 12.5 kilowatts, or you can simply say 1.25 times 10 raised to power 4 watts. So let's look at our option. So we have 1.25 times 10 raised to power 4, 1.25 times 10 raised to power 4 watt, which is option A. So that is also question number 24, which says, when the brakes in a car are applied, the frictional force on the tire is A, a disadvantage because it is in the direction of the moving of the car. B, it is a disadvantage because it is in the opposite direction of the motion of the car. C, it is an advantage because it is in the direction of the motion of the car. And D, it's an advantage because it is in the opposite direction of the motion of the car. So when you apply the brakes on a car, the frictional force is an advantage because it's in the opposite direction to the motion of the car, and it allows the car to come to a halt. So the correct answer to that question is option D. So that is also question number 25. It says, if the stress on a wire is 10 raised to power 7 Newton per meter square. So the stress on a wire was given. If the stress on a wire was given as 10 raised to power 7 Newton per meter square. So we have been given stress to be 10 raised to power 7 Newton per meter square. And the wire is stretched from its original length of, so our L1 was given here as 10 meters, and our L2 is 10.05 meters. It means that my extension is 0.05 meters. Okay, the Young modulus of the wire is dash. So we are looking for our Young modulus. We do not know, but we know that Young modulus is stress over strain. And for us to get our strain, we know that strain is equals to extension over original length, which is L1 in this case. So that will give me 0.05 divided by 10. So if I apply this here, it means that my Young modulus is going to give me 10 raised to power 7 divided by 0.05 over 10. So that will give me that my Young modulus is 10 raised to power 7 divided by 0.005. So looking at this, I have 10 raised to power 7 divided by 0.005. So that will give me 200,000,000, which is the same as saying I have 2 times 10 raised to power 9 Newton per meter square. So the correct answer should be 2 times 10 raised to power 9 Newton per meter square, which is option D. So we have come to the end of today's class. Don't forget to go to our channel for more videos just like this so that you will be properly tutored for your examinations.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 types of different exams, including JAMB, WAEC, Cacao,